All right, so we are going to start at the top of page 221, where it talks about biconditional statements. You can see a biconditional statement is a statement that can be written in the form P if and only if Q happens. Now, knowing the definition of biconditional, I guess, is important, but really what we're more concerned about is this particular biconditional statement. It says two triangles are congruent if and only if the corresponding pairs of sides and corresponding pairs of angles are congruent. So for instance, think about the pages of a book. Even though the content, the words, the diagrams on two pages may be different, two pages of a book are considered congruent because the length and width are the same of every page, and every page has 4 right angles in the corner. So it's not about what's necessarily design is on a shape, it's about the measurements, the angle measurements and the length measurements. So as we switch to example 1, I want you to go ahead and read through this example on your own. It says to determine whether the given triangles are congruent and then explain. Don't worry so much if you're not exactly sure what you're doing yet, because this entire example is worked out for you. So just read through this, pause this video, and we're going to look at example 1B together here in just a second. All right, so example 1A, you should have seen that those two triangles are congruent. And again, that's because all of the interior angles are congruent and all of the side lengths of each triangle are the same. So we're going to look at example 1B and do the same thing. Determine if these two triangles are congruent. So the first triangle is triangle ACB, and the second triangle is triangle EFD. The directions say compare corresponding sides first to decide if they are congruent. So the first side they give us is the distance from A to B is equal, we can see, to the distance from E to D, and both of those distances are 12.1. So since the distances are equal, the segments are congruent. So we're good there. One thing we want to get in a habit of doing when segments are congruent, we're going to use a vertical hash mark and draw it through each one of those sides. All right, so next we have the distance from A to C is equal to the distance from D to F, because both of those are 7.9 centimeters. So segment AC is congruent to segment DF. And again, this time I'm going to draw 2 vertical hash marks through those 2 congruent sides. But then we get stopped at this last segment because the distance from B to C is 8.5. And of course, that's not equal to the distance from E to F, which is 8.4. So those distances are not equal. So BC is not congruent. Segment BC is not congruent to segment EF. So the triangles are not congruent for a couple of reasons. Well, one, not all 3 corresponding sides are congruent. But what we also can say is we have no information about the angles. So since we have no information about the angles, even if the 3 sides were congruent, at this point we can't say the triangles are congruent because we don't know anything about the interior angle. So just remember, again, 2 triangles are only congruent if all 3 sides are exactly the same and all 3 interior angles are also exactly the same. All right, so let's flip to the next page, page 222. And there's 2 your turn examples, number 4 and number 5. on this page. Again, I want you to pause the video, and here in about 10 seconds, I'm going to go through number 4, but I want you to try it first on your own. So number 4, the answer is yes, those two triangles are congruent. And I know they're congruent because all corresponding sides and angles are congruent in this problem. For instance, there's a couple of different ways to state this, but segment RS has a vertical hash mark through it. Well, there's several segments that have a vertical hash mark, one single vertical hash mark through them. Let me just pick one in particular. You could say RS is congruent to VU. You can say segment TS is congruent to segment VW because they also have single hash marks through them. And of course, all of these segments are congruent to each other as well, since they all have just that single hash mark drawn through them. And then we have segment UW and segment RT, both have two vertical lines drawn through them, so we know those are congruent. We have both of these triangles have two 71-degree angles that are congruent to one another. And then both of these triangles have a 38-degree angle. So all corresponding sides and all corresponding angles are congruent. And then the last thing we're going to write, this is going to be talked more about in the next section, the congruency statement. We've shown that these two triangles are congruent. So I'm going to say triangle RST is congruent to triangle UVW. Notice the order of the letters. Technically, you can switch up the order a little bit, but the first letter is R and U, and those two angles are both 71 degrees. Angle S and angle V, those are both 38-degree angles. And angle T and W are also congruent angles. So we'll talk more about that congruency statement. Try number 5 on your own. I'll show you the answer here in about 5 seconds. So the short answer to this problem is no, those triangles are not congruent. The explanation, you can give a number of different reasons that these two triangles are not congruent. So you could say there's two of the side links in both triangles that you have no information for, right? We know that BC is congruent to FE because of the vertical hash mark. They give us nothing about the other two sides of the triangle. So even though the triangles may look like they're about the same length, we can never assume without either a number given to us or the vertical hash mark. And then number 2, we have all two of the angles are different angle measurements. So for instance, angle B is not congruent to angle E. And then you can say the same thing, angle D is not congruent to angle G. Again, only one of these things has to be true for these triangles not to be congruent.